Hello. Okay, I'm going to do an example here of this Gauss-Jordan method. And this is really just a reformulation of the elimination method for equations. So I'll show you how this goes. This is kind of our introduction to matrices. So here's this system of equations. So the first thing I want to do is I want to transform this system of equations into a matrix by simply more or less dropping some of the symbols. So watch what I do here. I take, and I'll put I'll get my pen out here. So I'm going to put the number 1 here, and that comes from the fact that there's a 1 in front of the x. I'll put a -1, 5, -6. The dotted line here, that's to remind us that that's where the sort of the equal sign is. So this first, what we say, row of this matrix, augmented matrix, is the fact that there's an equation involving x, y, and z in this case. It's 1x minus 1 times y plus 5 times z is equal to -6. Now we do the same thing for the second equation and for the third equation. And what we're looking at here now is a box of numbers that represents it's something we're going to work with that represents a system of equations, okay? And what we're trying to do is solve this system of equations. And so what we're going to do is we're going to mimic what we did for the elimination method and just perform things on this box. So essentially what we're going to do is we're going to try to eliminate some variables. And I'm going to use a similar notation as I did before, okay? So what I'm going to do is I'm going to start with this matrix, and I'm going to replace it with a new one that has the exact same solutions, okay, to the system of equations that it is associated with. What do I mean by that? I'm simply going to replace the first equation. I'm going to be writing E1. So I'm not going to change the first equation. Let me show you what I mean. 1 minus 1. What's next? 5. Okay. And -6. Now, what I'm going to do is I'm going to use the following notation. Just like you did when you work through those questions or problems with elimination, you found yourself multiplying, say, one equation. So, for example, if I multiplied the top row, now these aren't equations, but I'm still using this E to represent the first row. If I multiply every element of the first row by -3, and if I add that to the second row, E2, or that comes from the second equation, then watch what happens. You see, I would get -3 times 1, okay, plus 3. That introduces a 0 here, which should remind you of eliminating the variable x in the second equation. If you follow through the sort of notation that I'm following here on the right, and if you leave the variables in there when you're doing this procedure with the elimination method, you'll get the following equation. You'll see that you get a 0, and then you will get a 6 here. If I take -3 times -1 plus 3, I get a 6. I get a -16 here because that's what -3 times 5 minus 1 is. And then over here on the other side of the dotted line, or what would be the right-hand side of the equation, you would get a 28. Okay? Now, the strategy is to introduce zeros below. Well, let me tell you what a definition. This, you see this here? This is what we will refer to in the future as the diagonal of the matrix. Notice how I'm just going the diagonal. So what I'm trying to do is, essentially with this box of numbers, is put zeros below the diagonal. That corresponds to eliminating the variable x in the first equation, and then eliminating the variable x and y in the second equation. So I'll put a 0 right here. So you work with the first entry here, and you're going to put a 0 here. And how I could do that is simply by taking, let's see, okay, I have a 1 up there in the, oops, sorry, I have a 1 up here in this entry in the previous matrix. So I'm going to take just that row, -1 times that row, or just -E1, and I'm going to add that to E3. Now I'm going to write the result of that, and you should verify this by doing the calculations. You can stop the video, for example, and confirm, see where I'm getting these numbers from. 0, 4, negative 3, and 11. For example, I'll show you where this negative 3 comes from. Well, if you take negative 5, which comes from this negative 5 here, but minus 1 times 5, and if you add that to 2, you get negative 3, and that's where that comes from. Okay, so the next thing I'm going to do is I'm going to, as I indicated, I'm going to try to put the zeros, a 0, and replace this 4 with a 0. That would correspond to, in the system, eliminating the y in the third equation. So if you've done enough of those, you realize that's sort of the technique. Maybe we haven't done too many with 3 equations and 3 unknowns, but the process just continues. Okay, so I'll leave the first 2 equations alone, and then I want to put a 0 here. So there's, what I'm going to do is this. I'm going to take minus 4 times equation 2, and I'm going to add 6 times equation 3. Now that should look familiar. In other words, if I take minus 4 times 6, that's a negative 24, and if I take 6 times 4, that's 24, and if I add those 2 together, I certainly get a 0. Then I get a 0 here, and well, you can confirm that I would get 46 here and a negative 46 here. Now the point of this is that at each stage, each of these boxes of numbers, this augmented matrix, corresponds to a system of equations that has the exact same solution set as the previous one. Okay, and what you're looking at, you're seeing that it's starting to look a little bit simpler, or whatever that means. There's more zeros. Okay, so just hang in there with me. I'm going to go through the process, and you'll see the magic involved here in a second. The next thing I'm going to do is very simple. I'm just going to try to turn this 46 into a 1. Okay, and that's accomplished fairly easily by I'm just copying right now. Just multiplying by a negative, well, dividing by what? 46. Okay, so here I go. 0, 6, minus 16, 28, and then finally I just get 0, 0, 1, minus 1, and that's obtained by taking and replacing this row 3 by the previous row 3 divided by 46. Okay. Now what I'm going to do is I'm going to try to introduce zeros in the what we would say in the entries above the diagonal. So I'll do that for us here, and then you'll see why that's a nice thing. Okay, so the rules I'm going to use, and I'll explain where I'm getting these after I write them. Okay, I'll just write them down, and we'll take a look at it. I'm going to take minus 5 times E3. Plus E1, and I'll put it right there. E1, that is, not 1. And then here I'm going to take, I guess, 16 times E3, and I'll add that to E2, and that's going to put a 0 somewhere. And then here I'm just going to rewrite E3. Now let me show you why that is. Okay, so we have a 1 here. Now I'm sort of working backwards to put zeros above the diagonal. Now let's take a look at this one. See, if you stare at this 1 and this negative 16, you can see that if I take, I'm using this 1, so if I take 1 times 16 plus a negative 16, that's 0. Okay, so watch. Doing that, since there's already zeros in this spot and this spot, that leaves my 6 standing there. Then here I get a 0, okay? And then here I would get a 12, because let's see if that makes sense. If I take minus 16 plus 28, yeah, that's 12, okay? Now let's look what happens for the first row. You see, for the first row, I'm trying to put a 0 right here. Now how I accomplish that is if I take minus 5 times this 1, that's right, I got the minus 5 times E1, plus, times E3 that is, plus E1, I get a 0 there. So I get a 0 there, okay? Now what do I get here? If I take 0 times, well, nothing changes there, so I still get a minus 1. And then nothing changes here because there's a, why doesn't it change there? Well, because I'm using the third row and there are zeros here. So when I take a multiple of 0, it's just 0. And so it doesn't change those first two entries. All right, and then finally here I get a minus 6. And you can confirm that, in fact, that's the case, but that's not too bad. That's just, if you take, let's see if that works. If I take, wait. Okay, good. I'm glad I looked. That's not minus 6. Look, if I take a minus 3, I'm sorry, minus 5 times a minus 1, okay, that's equal to 5. So then if I subtract 6, as I'm indicating here, I would be left with, in fact, a minus 1 there. So one thing you'll realize when you're doing these is it's very, very, in my opinion, possible to make an error. So be very careful. That's all I can say. So this is actually a minus 1. Okay, now finally what I would like to do is make sure that I have all 1s across the diagonal and 0s everywhere else. Okay, so what I'm going to do is I'm going to do a couple of things. I'm going to take, for example, I'm going to take, in the second one, I'm going to take the equation E2, right, and I'm going to divide that by 6. That's an easy one. That would leave me with 0, 1, 0, 2. Okay. Now I'm leaving the third equation alone. 0, 0, 1, minus 1. But now the first equation here. Oh, I'm going to break a little rule here of my own. I guess I won't. I'm going to do the following. I'm going to turn this into a 0. So to do that, I should take, well, let's see. Let's take, if I start with this, if I take E2, and if I divide that by 6, and if I add E1, then I get 0, 0, 0, and let's see. Okay, so I'd take 12 divided by 6, which is 2, plus E1, which is minus 1, that'd be 1. So that was a kind of a difficult one to see, but not too bad. All right, so what have we accomplished here? Well, nothing at this point because I made another small error. This did not change into a 0, it's still a 1. Okay. So what we've accomplished is we've transformed this augmented matrix into something of this form. And now we look at what the system of equations is related to this one, and it's just the following. It's that x equals 1, y is equal to 2, and z is equal to a negative 1. So what we've done by using this augmented matrix is we've solved this system of equations here, okay? And let's just quickly confirm, that's not a 0, that was a circle that I made. Let's confirm that this, in fact, is a solution. Well, let's see. If I take 1 for x, so 1, 2, minus 1. Let's see, I'll write it up here now. So we're getting 1, 2, minus 1. So we're thinking x equals 1, y equals 2, z equals minus 1. Let's just see if that works. Let's look at this equation. In our minds, let's see, if I take 1 minus 2, and then I put a minus 1, 1 minus 2 minus 5, is that equal to a negative 6? And did I actually write my solutions out right here? Well, let's see. 1 minus 2 is minus 1. Minus 5 is minus 6. So that equation works with these three. Now we have to check the second one. So if I take 3 plus 6, okay, I'm putting out 3 times 1 is 3, plus 3 times 2, that's 6. So what is that? So that's 3 plus 6 is 9. And then if I add 1, oh yeah, I do get 10. Let's check the next equation. 1 for x plus, let's see, 6, so that's 7, plus, or actually minus 2, and that's 5, so it works. Okay, so this is an example of the Gauss-Jordan technique applied to matrices. You may find that you'll need to look at some of the resources that I've put in the website there to get good at this. But with practice, it's actually quite enjoyable. So thank you very much. If you have any questions, of course, contact me and we will get a chance to talk on the Adobe Connect. Thank you very much. Bye.